All right, so here is problem number 3. Let's be careful here. We want the acceleration of the object from 5 to 8 seconds. Again, the acceleration, that means the slope of the velocity graph. And I'm seeing a little bit of work here that indicates to me that you've forgotten how to calculate the slope using the correct formula. So this point here is 8, 0, and this point here is 5, 2. And I'm just going to be clear, on your next practice exam, I'm going to be really clear that I do not want you counting squares and that I want you to use the proper calculation. So let's just go back to math class. When you have a line and you want to get the slope of that line, this is x2, y2, and this is x1, y1. And so when we're calculating the slope, I want you to start using the formula y2 minus y1 over x2 minus x1. I want to start seeing your work done like that because I'm not convinced you can actually do that still, and I'm seeing some careless errors because of that. So the acceleration here is going to be 0 minus 2 over 8 minus 5, and that's giving me negative 2/3. We don't want decimals in physics, so this should be negative 0.67 meters per second squared. One thing, I'm not going to take off points, but I do not want to see this repeating decimal, okay? We're going to start using sig figs more carefully next semester, so I do not want to see this little bar here for the repeating decimal. Okay, we round. Now, is the object moving from 0 to 5 seconds? The answer is yes, at constant velocity. So for part C, we want to get the displacement of the object from 0 to 8 seconds. So we have a rectangle here. Let's notice that it has a length of 2 and a width of 5. Now that's 2 centimeters per second, 5 seconds. And then here we have this base of 3 and again a height of 2. So let's put all that together. Our area, which is the displacement, is going to be 2 times 5 plus the area of the triangle, which is 1/2 times 2 times 3. When we put all that together, we're going to end up getting 13 centimeters. One small thing that I want to note, on your test, I actually give you all the area formulas that you need. So I won't be providing any help on this on the test. If you forget what those formulas are, please make sure you're looking at your formula sheet right here. All right, now, the next thing. Does the object ever come to rest? Well, it comes to rest at 8 seconds when v equals 0. So yes, at 8 seconds when v equals 0 meters per second. Next, does the object ever go backwards or change direction? No, it does not. It's always moving forwards. Right here, I saw some people think that it slows down at 5 seconds. So I'm going to make a small point here. Note, at 5 seconds, it starts to slow down, but does not change direction. And then for part F, the answer is no, never from a velocity versus time graph. All right, so that's it for question number 3.